Hello, it is with great pleasure today we have Professor Gill to this interview. Thank you very much for joining us.
Thank you very much for having me.
So
I'm excited.
Professor, Professor Gill, please tell us a little bit about yourself.
Yes, I'll tell you. I'll try to tell you a little bit about myself. Of course, I'm 71 actually, and I'm a retired professor of mathematical statistics at the University of Leiden in the Netherlands. But as you may hear from my accent, I'm a native English speaker, and you can see from my name also. So I have British and Dutch nationalities. I was born in 1951 in England. Went to school, went to university, Cambridge University. While I was at Cambridge University, I had a Dutch girlfriend, and when I finished my studies in 1974, my girlfriend had not finished hers, so I got a job as a PhD student in Amsterdam. That was 1974. So since 1974, I've been living and working in the Netherlands, and still living with the same girlfriend with whom I have 3 children and 5 grandchildren, which gives a lot of fun things to do.
That sounds like a very romantic story we have.
Yeah, okay. Well, marriages have their ups and downs and so on, So it's
All right. So our next
we are very good at we are good at fighting with each other, but we also make it up always.
I'm sure you
Yes.
I'm sure you two are happily living together, more or less.
Oh yeah, very very happy.
So our second question is, please tell us a little bit more background on quantum statistics and what makes you want to research quantum statistics. Did you get any influence from other people?
So as I mentioned, my official chair at university was in mathematical statistics, and in Cambridge University, I studied probability theory, mathematics generally, and statistics. And I became particularly interested in statistics because, on the one hand, you had the beautiful mathematics of probability theory, Kolmogorov, sigma algebras, all that stuff. Lovely, nice theory, measure theoretic probability. And on the other hand, you had applications, and you had even ethical questions. In statistics, you have to choose alpha and beta and so on. And these are choices which have consequences for other people. And it's like an ethical choice where you put a cut to decide to send somebody to jail or let them go free, for instance. And one has to do this, and society does this. So this is how I got interested in statistics. And for a long time, I was working in you could say, medical statistics. And at some point, maybe now 25 years ago, I was getting a little bit bored with what I had been doing. And a friend of mine gave a talk in a seminar and told us about quantum probability. And he said, in the physics lab, and he talked about real experiments, in the physics laboratory, there is also probability. In quantum physics, there's also probability, but it has different rules, and different rules from the rules of Kolmogorov. And I was amazed and perplexed. I just did not believe this. But it led me to, it got me so excited that I started studying it. And in fact, he was, my friend's talk was about Bell inequalities and Bell's theorem and all that stuff. And I came to the conclusion that it was not an issue that probability in quantum physics follows different rules, because it's just the same rules. I mean, the rules of probability are like rules of accountancy. They're just like you add things up in different ways, you get the same answer. They are very, very basic, simple rules. Anyway, so I got involved to begin with in this issue of Bell's theorem and the meaning of it. And very rapidly, I met a few more people, colleagues in statistics, who were interested in this. So that's how I got into it. And what I mean by quantum statistics is my own word for the kind of area I'm working in, I'm interested in the interplay between classical probability and quantum mechanics, and classical statistics and quantum mechanics. So I'm interested in what should statisticians do who are analyzing data from quantum physics experiments. And the most exciting experiments are the ones connected to Bell's theorem and so on. And this is that theorem, that field has become extraordinarily important because of quantum computation and quantum information. So there's a field of mathematics called quantum information. There's a field of computer science called quantum computation. And these are mathematical structures. And at the same time, you have people in the laboratory starting to build things machines which can do computations based on the behavior of very small particles and strange properties of quantum mechanics. So that's where, so that's for me what quantum statistics is, but it means I'm working partly in like the foundations of quantum mechanics. So that's sort of the philosophy of science. There are lots of people working in the philosophy of science, trying to make sense of what does it mean, and so on. And then there's quantum information itself, which is like the mathematics of what you can do with quantum systems, especially with like a reasonable number of very small quantum systems. You can make them possibly factor large integers much faster than we can do on classical computers. So there's promise of exciting technology, and there are experiments going in that direction. So all these things come together, and it's a very vibrant and exciting field. And quite early, I was able to collaborate with some quite famous people like Zeilinger, Gill, and so on. So these are leaders in quantum optics. We've done some work together concerning Bell's theorem and Bell experiments, and but I also work with statisticians and mathematicians.
So my next question is, what are the challenges that you are facing in the current situation?
The current situation, well, my main challenge is age. That's a challenge. I have had two major challenges. One was, as somebody from statistics, classical statistics, who started working with quantum people, always I felt my mission was to tell my colleagues back in ordinary statistics that here were exciting things and they should get involved and do work. And so I tried to kind of lead the way. With some colleagues, we wrote a big paper on quantum statistics, and we wanted to encourage the next generation of people like me, but also to start collaborating with the physicists, because there were so many things you could do. But this was not successful, I must say. I mean, almost nobody made that jump. There is some problem in the mind of people who are trained in classical statistics, that they are scared of physics, and they are scared of physicists, and they are not trained in the kind of mathematics which the physicists use, and they know it is very difficult, and they find it a bit scary, and they have heard things like quantum physics is weird and entanglement is nobody understands it, and so on. And they heard things like probability in quantum theory is not the same as probability in tossing dice and coins and things. And so there is a lot of fear in my old community, which is keeping people from getting involved. And it's strange because the computer scientists, they got involved in quantum computation in a big way. But the statisticians did not get involved in quantum computation. It's just starting to happen. It's a bit late. I mean, but of course, they had other things to do because they could all work in molecular biology and genetics and so on. There was so much things that statisticians could do in the real world in science, which was very, very important and very clear that it was their business. That was one of the reasons why not many people followed my path. Yeah.
Well, I'm sure a new generation of passionate scientists will follow your path, will be just like you.
I'm sure. I know. Yes, they will. They have a hard time.
So,
But
so will further research be needed in this field, and is there a next move from you?
oh yes. Certainly, much more research is going on, and it is very, very exciting. We still don't have a quantum computer which does something which a classical computer could not do, right? And people are talking about when is it going to be? Maybe in 10 years. Well, they always say like in a number of years, which is so large that they can safely say it will be in 10 years. I think 10 years. But there are serious scientists who say it's not going to happen because as you scale things up, the noise starts to increase and various things are not going to scale. So maybe this whole quantum computation hype is just a hype and it's going to lead to big disappointments. But it's scientifically very exciting. Is it just the pure physics questions? Can you do this? Yes or no? And the whole, the mathematics around there and computer science around there is extremely dynamic and big. And there's going to be lots more to do for many more years. And not so much for me, because at the moment I'm also working a lot on some forensic statistics issues, and I'm working, I'm advising lawyers who are having fights about situations where science is being abused and statistics is being wrongly interpreted.
But last but not least, is there any acknowledgement you would like to make?
Oh, well, I don't know. So I think I made a very good career, and I got quite famous in some ways. And one of my colleagues went at a retirement party, told a little saying, which is, "Behind every great man there stands a surprised woman." So I will thank my wife, who is quite sort of happy I made some successes, but often rather surprised that such a crazy, chaotic person could do that. So that's my acknowledgement.
All right. Thank you very much, Professor Gill, for joining us today. And we wish you a happy retirement life. And I wish you
yes.
And I wish your wife just as happy as you are.
Yes, I think she is.
Cool.
Thank you very much.
Fantastic.